Okay, so next page, section 2.3, linear functions. We're just going to get through, gosh, I believe it's just the first page of this. So we're going to save the last 2 pages for Wednesday. So Wednesday, we'll probably have time to answer questions. So if y'all have different questions, please ask them on Wednesday. And then remember that Friday is just a review day. So here we go. Linear functions. So we've got 4 objectives: calculate slope of a linear function, write a linear equation and slope intercept, point slope in general or standard forms, graph a linear equation including horizontal and vertical lines. So now, like I mentioned last week, graphing linear equations, up to this point, we were just plotting points. Now we're going to learn with slope intercept, like we can plot the y-intercept, and then now that we technically know slope, we can use rise over run for plotting and graphing. And then last, model data with linear functions and use the model to make predictions. So we've got 2 definitions here. Linear equation with 2 variables. It's an equation with 2 variables that can be written in the form ax plus by equaling c, where a, b, and c are real numbers. That's what this says, basically, are real numbers. And they both cannot be 0, right? They both cannot be 0. Because if they're both 0, then essentially we just have 0 equals hopefully 0, right? It's not a linear equation anymore. So linear, we can have ax equaling c or by equals c, right? Linear lines. And slope, y'all may be familiar, but if not, that's why it's on here, sorry. So the ratio of the vertical change to the horizontal change between 2 points is called the slope of a line connecting these 2 points, referred to as the rate of change in applications. And rate of change, right? So slope, rate of change. If y'all are moving into calculus, there's instantaneous rate of change. Later on, I think that after the test, we learn average rate of change. But for right now, since slope is specific for it is non-changing for a linear equation, right? We just have a line. It is just the rate of change. But we'll go into deeper definitions later. Okay, so the formula, or the definition, excuse me. The formula for slope m of a line, if a line passes through 2 distinct points, point 1 being x1, y1, and point 2 being x2, y2, then the slope m of a line is given by the formula m equals delta y over delta x, which is change in y over change in x, which is the vertical change over the horizontal change, or rise over run, or more specifically, y2 minus y1 over x2 minus x1. Okay, so if you have a problem remembering which is top, which is bottom, vertical, right, up and down first, then left to right, I have a funny little anecdote for you. So if you're familiar with Duck Duck Goose, right, little children, they sit in a little circle. Here's our little children's heads. And then someone is the person running around, and they walk around, and then maybe they tap this person on the head and they go, goose, right? Aren't they goose, not duck? Yeah, they're goose. Well, then this person stands up and then they run. Right? So it's rise over run. So you're not going to scoot along on your bottom if you're the one who's goose, right? You're going to stand up and then run around, right? Because the point is to like make it back to your chair or your seat before the person who goosed you catches you, right? I think, yeah. I'm sorry, it's been a long time since I played Duck Duck Goose. But anyways, it's rise over run. So it's vertical over horizontal. But slope is essentially just comes from triangles. Almost, you'll notice a lot of things come from triangles. So, right, this is All right, like if this is our line, if this is y equals f of x, if this is our line right here, well, I can just choose any 2 points on that line. And to find the slope or the ratio of the change in y over change in x, well, it's just the difference, or y2 minus y1 in the vertical with the difference in the horizontal, x2 minus x1. So rise over run. It's just kind of, you're saying the difference in the triangle essentially. But also here, you can have y1 minus y2 over x1 minus x2. Just notice your points have to be aligned, right? So 2 with 2, 1s with 1s, no commingling. Okay, no commingling there. All right, that's slope. We use the letter M. Don't ask me why. We use the letter M for labeling slope. Okay. So page 1 continued. Find the slope of the line passing through each pair of points. So -3, 1 and -2, 4. Remember, this is just change in y over change in x. Slope M. So it is 4 minus -1 over -2 minus -3 equals, this is what, 4 plus 1 and -2 plus 3. So what, 5 over 1. Okay, so then the slope is 5. The slope is 5. Or 5 over run, you can think that we rise 5 for every run of 1. So you rise 5 and then run 1 in graphing, right? So it would be rise 5 and then either left or right, depending if we're increasing or decreasing, run 1. So I know we get into this a little bit later, but just suppose here's the point. So it'd be 1, 2, 3, 4, 5, then over 1 for increasing to the left. If it was decreasing, right, we would just go to the right. 1, 2, 3, 4, 5, and then connect that way. So it would be, what did I say? Right for increasing and left for decreasing. Assuming we start from going up. Okay, so pause the video. I want you to try B, and then when you are ready, you will just press play. So you either waited for my short little pause or you paused the video in your breath. Either way, I hope you tried it. So slope is y2 minus y1 over x2 minus x1. So if this is 0.2, this is 0.1, but really it's arbitrary. We've got -2 minus 4 over 2 minus -3. So -6. What? That's really 2 plus 3, which is 5. So -6 fifths. Yay. Right, -2 minus 4, -6. 2 minus -3 is 5. Perfect. Hopefully y'all got that as well. So again, this means that you rise 6, and then here we would go right 5 because of the negative. The negative slope tells us decreasing. Okay. The negative slope tells us that we are decreasing. We are going in a negative, so we're falling action. Cool. And then there's 2 special slopes. So special slopes, meaning one is a slope of 0 and one is a slope of undefined. So we are a slope of 0 if we have a horizontal, if we have a horizontal line, just meaning like y equaling c. So if I plot down some axes, let's say this random number is c. Okay, it can be 1, it can be 5, it doesn't matter. Well, that just means we have that horizontal line at c, or you can think y is constantly c. X is everything, so to speak. Okay. So notice there's no rise. There's no rise because it would always be y2 minus y1 would always equal 0 because you'd have c minus c equaling 0. So hence the slope is 0 because your slope of m would be 0 over whatever the number is, doesn't matter. Now over here, undefined, we have that vertical line because there's no quote run. So this would be an example if it was like x equals c. Let's just call this c, whatever. It can be 5, can be 2, doesn't matter. But if this is c, same argument as here, but over here, except it is with the run. There's no run. We're all rise, right? So x2 minus x1 would always equal 0, right? Because you would always have c minus c equaling 0. So that's why it gives us the slope of whatever number divided by, well, I don't even like writing it, divided by 0. But what's the one number we can never divide by? 0. So that's why we call it undefined, okay? Because we don't divide by 0, it's undefined. So these are our special slopes. Slope of 0 and a slope of undefined. 0 slopes comes with horizontal lines, and undefined slopes come with a vertical line. Okay, so last little bit here, point slope form of a line. It's almost as if it comes from slope form. Okay, it's almost as if it comes from, slope. So point slope form is y minus y1 equaling m times x minus x1. Okay, so it's almost, pretend with me, I'll do it over here in the cloud. So we know that slope is y2 minus y1 over x2 minus x1. So just imagine you now only have 1 point. Okay, just imagine you now only have 1 point. So we push pin down a y and an x. Okay, those now are just input, output. Next, we'll multiply to the left. So we have m times x minus x1 equals y minus y1. So it essentially, we can think of it as it comes from slope, but instead of having 2 points, we now just have 1 point. Okay. Again, way back in the day, they called it like they saw it, right? It's called point slope form because we use it when we have a point x1, y1, and slope m. So if we have these two things, it's then just kind of plug and chug. We plug in y1 respectively, x1 respectively, m, and then we just simplify a little bit. If we were to keep going, if we were to solve down all the way for y, we would then get the next page, which is the slope intercept form. Okay, slope intercept form. So we'll pick up with examples of this on Wednesday so that we can do, more of the concrete stuff together. But so I'll just leave you with this definition. So point slope form is, they called it like they saw, it's called point slope form because you have a point and a slope and you pop it into the equation. That's pretty much it. But that's the lesson for today. I will see y'all in class hopefully on Wednesday. Hopefully this is just a one-off random fever my son has. But y'all have an amazing day. Please email me if you have any questions or hold them till Wednesday. No office hours today because I'll be taking care of my son. I'm technically taking a sick day, but I just wanted to get this video up for y'all. Yeah, y'all have a great day. I'll see you Wednesday.